We're going to see the deployments today and all the terminology, all the areas related to deployment. There are a lot of questions that will come out of the deployment. There are a lot of new terms related to these deployments. I just listed out kind of a very quick list of here. SCA, this service connection architecture. Composites are the packages. It's like the application that you get. A SOA application is usually called a composite. Then composites internally have components. The SOA components. You got BPEL, mediator, human workflow, decision service. So all of them together, or some of them together, will form a composite. Then you got revisions. So it's like versions. Revisions are like versions. Then there are partitions. Then partitions are logical groupings. I will go into details in each of those things, but just as a summary kind of. Then instances. Instances is when a composite gets called, an instance gets created for that composite. Then faults. So when these instances fail, faults are created. Then rejected messages. When these instances receive or send what we say wrong inputs, it gets rejected messages. A dehydration store. Dehydration store is a group of tables in the database or in MDS that stores the state of these instances. These are all various terms that we talk about. These are various fundamentals we'll learn in this, and we'll also see how to deploy an application. Alright, so here now the first thing that gives you a clear understanding of a composite versus an application is this one. Normally if we see Java applications, they're all enterprise applications, JEE applications. So we have all kinds of Diwali started, guys, sorry. Oh man. So our enterprise applications, Java based applications, we usually get it in WAR files, ER files, RAR files, resource archives, jar files. This is a common bundling extensions, and each of them have different technologies. This is all Java code. Right. Then we get these Java code, we deploy it to WebLogic application. So through a regular, any of our methods using console or using an AND tool or whatever. So the content or the code inside these applications is purely Java. Now, as compared to a Java code, what is usually called an enterprise application or a Java-based application, a SOA application is called a composite. And before we go into a composite, a SOA application gets created using what is called a service component architecture, SCA architecture. Can you guys put yourself on mute? A slight background noise. Okay, cool. So here, before we go into composite and the way it's bundled, there is something called service-oriented business application. Now normally if you take a Java application, it's also a business application. It also tries to achieve a business functionality, but we have a different type of achieving the same business functionality. The different type is what we call a service-oriented business application or a service-oriented business mechanism. If you, for example, if you see the regular eBay application that we all see. Let me get back to that eBay application. This is the eBay application. If you see this one on the right side, this is more a technology oriented way of defining our business functionality. You have order management, delivery, tracking, feed. This is a technology. It's more like a JEE flow. All of them assuming JEE application. So you might have a front end that for passes through, as opposed to this JEE based business functionality. If you look at this one, the left side, this is a service based business functionality. In a way, you will first say call the order management, which is here, then call the delivery module, which is here, call the tracking module, which is here, call the feedback module, like this. So here the same functionalities are the same softwares, but they are being treated as services by using adapters. So SEE has a different approach. That's it. We are still doing the same business thing. We are still trying to achieve the same business functionality, but here everything is homogeneous. Everything is a service. So the business functionality here we are trying to achieve in a service oriented manner. Everything is simply like we are calling it service, we are calling it Y service, we are calling it Z service, like that. Where we don't discuss about the technology that's being used. Everything is a service in its way, because any software, any technology can be exposed as a service. Now those applications which are designed based on a service oriented architecture are called SOBAs, or service oriented business application. And to develop such an application, we use SCA, the service component architecture. You have components by components. The flow is decided by components by components. Now the jar file, or usually the jar file that you get for SOA, is based on SCA architecture. You will get a jar file something like this. Let's say like this. This is a jar file you will get from a developer, which is a SOA component, sorry, SOA composite. And the same thing usually we'll get it in JEE based applications also. You will have some name with it, a var or an AR or a rar. Here also the extension is same, but the contents inside are not Java here. The contents are more like are going to be based on a BPEL. And how we create a BPEL program, we have seen a video already, a drag and drop model of JDeveloper or NetBeans kind of tool. So inside this, this composite is designed based on the SCA architecture, service connected architecture. So here our service component architecture, you call it service connector, you call it sometimes. So here inside this jar file you have a large group of components. Remember here, just observe the slight differences that I am using. There is a component and there is a composite. So let me come back to the original slide. Here we are. So our composite is developed based on SCA architecture, and those composites are nothing but, in a generic way, the business applications, service oriented business applications. So here you got Java applications, which are JEE applications, then SOA applications, which are called composites. So from now on, when you are an administrator, you don't call an application anymore, and it's because that's not Java. From now on you will be calling composites. So you will say A developer will deliver you the composites. You will deploy the composites. You undeploy the composites. That's how, the composite from application, your jargon or your usage now revolves around composites. So the composites are nothing but the files that you get from the developers. These are applications. Now obviously a composite internally will have the components. Depending on what we are trying to do inside a composite, you may have one of the internal 5 components. We know SOA has 5 components: BPL component, mediator component, human workflow component, decision services and business rules component, Spring context component. There's 5 components. Now a composite, which is an overall application, will use components inside it. You may have all the components, or you may have some of them. Alright, the overall composite again is written in the business process execution language. So from now on, your deployment revolves around composites. It's not Java applications anymore. Now this is a composite structure and how usually a component internally works. This is just a basic building block. Let's say this can be a human workflow component, or it can be a mediator component. So if we have a mediator, for example, say it takes inputs, it routes it, let's say, or it gives out outputs. So the incoming requests or incoming connections are called services. The outgoing are called references. References is where the request is being sent out. Incoming inputs are where they are called services. Now the implementation is usually in BPL. Now, so what we have here is a component is what we are looking at, the blue box here, and multiple such boxes together will form a composite, which is in the next screen. If you see, this is a composite, and this is what you will be given as a jar file. So there is a front end, or what you call a service end. There is a back end to every application or every composite, which is a reference. Good. So this is what you are going to get from a developer. So you have a component here, you have a component here, then all of them together is called a composite. Alright, when somebody calls this composite, they will be calling nothing but a service. So composites are normally, if you deploy a Java application to WebLogic, you will access it using a browser most of the times. Whereas if you deploy a composite to a SOA infrastructure, there is no browser based access as such, or it's not designed to be accessed using a browser. It's more like a web service. So you will use other tools like SOAP UI. All of us, I will show you, SOAP UI. So using SOAP UI, you send an XML input, and this composite replies with an XML output or XML response. So from now on, we are actually talking everything in terms of XMLs. And to talk to a composite, you will be sending an XML input to a specific URL. You will get much more clarity on that one as we proceed. Alright, this is one of the composites. Now if you see this composite, this will be deployed to our SOA domain, that's the one they have created. So you may have multiple composites again. You may have multiple composites. Alright, so let's say composite X, composite Y, one calling the other one. It all depends on how it's designed internally. Now if you see, there is another term here. It's called a wire. Wire is a connection between the components. It's called a wire. And this is all, the technical jargon. We wouldn't be really looking inside a composite, just like you won't look into a Java application very too often unless you are a developer. And this is how internal. This is more like a developer-centric design. Now, this entire thing gets bundled and given to us in a single bundle or multiple bundles, and we will deploy it to our SO infrastructure.
So Anil, the communication happens between components and composites as well, like according to this diagram, or like will it happen from composite to composite level?
Composite to composite at composite level. Inside the composites, you will have component to component level communication also.
Okay, so
Yes.
basically composite to composite, right?
Yes. At a high level, composite to composite. That's right.
Okay. So composite will be, I mean, components can be developed in any language, but the composite will be done using BPEL for the integration. Am I right?
Yes, that's right. The internal component implementation can be in anywhere.
Okay.
That's correct. That's correct. And yeah, Prasad, how do we identify components and composites? No, we will not be given components from the developers. So even if it is a single component, you will still get a bundle like thing, which we still call it a composite. You get it in a jar file. Even a single component, if that's the entire overall whole application, that will be bundled and given to you as a composite only, as a jar file. So component itself has no extension. It's the composite that will be given to us, and it has a jar extension or a zip extension, which is a bundle of composites. So here, if you say, each of these composites are usually bundled into jars, and you will be given multiple jars from a developer. Now these jars have a specific naming convention. Look at this one. A composite usually starts with SEA with the name, and there is a revision like version and the jar file. So this is one revision of a composite. This is the second revision, like versions. This is the third revision, and the naming convention is always same. So if you say, for example, one of our applications that we're going to use, sorry. Code IT apps. Now, if you say this application, this is one of a sample application we're going to use. SEA, the name of your composite, the revision. The same way this is revision 2. The same way this was revision 1. Like that. So all these composites have a specific naming convention. Now you may be given a single composites like a jar file, or all such composites can not, various versions. We are talking about, let's say, different composites, composite 1, composite 2, composite 3. They all can be bundled together, and you can be given a zip file, and you are allowed to deploy the entire zip file at a time. Means multiple components together can be deployed at a time using SOA infrastructure, and that zip file is usually called a SAR file. So there is no .ser extension as such. A SAR file or SCA archive is nothing but a group of jar files. Alright, each of them is basically a composite. Alright, so you will be given either single jar files, or you will be given a zip file which internally has lot of such jar files. If it is a single jar file, you call it a composite. If it is a zip file which internally has a lot of jar files, you call it a SAR file. Now you can deploy the SAR file. I'll show you the deployment, then we'll go into further things. That will make things easy for us. So the next screenshot that you're looking at is how we deploy. Let me do one thing. Let me send you this PPT so it will be easy for you guys to follow. Okay, download it from our location. The empty brain, and keep it open on your system. This one, the fifth one, this one. Day05 Deployment of composites. Okay, let's come back. So we're trying to deploy. Now this deployment is deployment of a composite that we're going to do. So we will be bringing up our admin server, we'll be bringing up our server infrastructure, then we will deploy it using console. So I'm going to get into the cloud server. This is the cloud server. Let me bring up the database first, then I'll bring up the admin server and the source server, then we log into the console. So let's do it quickly. Oracle /SSDBA. Start up. We will not be doing this one in real time because there is a DBA who takes care of this stuff. But here we have to do everything. So just keep your database related activities to the minimal. Alright, your database is up. Let's start the listeners. Alright, our database is up. Import IT, so these are the database related process. Let's get out and start our admin server. So I'll go to domain home where we have created our domain. Students online is where. City students line SY Oracle. So when you're practicing, make sure you create your directory here itself. Alright, just the way I have created OLSY, you can create your own directory and make sure you work inside that directory only. So go to Oracle, middleware, user projects, domains, import server domain, start the admin server. So I'm going to start this, and this is the content of the admin. This is simple wrapper script. We have seen these things. So open up this log, fnf admin dot. This is all web logic. This has nothing to do with this way. It says for your biggest headache is it takes too long for the servers to come up. At least for the SOA server itself, it takes very long.
That to now only admin only, right? We are doing.
Yeah, itself is taking so long.
Maybe we need to do this is the first activity when the class start, I think.
Yeah, that's what I was thinking. The moment we start, we'll bring up everything, keep everything ready. Alright, admin is up. Now let's start the source server. In the meantime, we can also log into that console. I'm going to use Opera browser. It's much lighter. I'll close this thing. So let's log into the internet. We got 7001 Enterprise Manager. Let's get to the enterprise. SOA admin to the login. Alright. So the S4 server is still coming up. You won't have SVA or BAM anything here. Only thing you will see is WebLogic domain. This thing. The other three server in the WebLogic domain. And our applications, internal applications are up at this point. Enterprise manager. These are actually deployed to the admin server. So from the servers we have both SVA server and BAM server still showing down. Once SVA is up, this should be up. Let's see SVA. This is our SVA server coming up on the front screen, booty screen. Okay. It's actually deployed. I have deployed it yesterday. I was just testing it. Let's refresh this page. If you refresh, you should see the SVA here on the left side. Yeah, here we go, the SVA infrastructure. Now if you see this one, this is SVA related stuff. Every server is called a SVA infrastructure because each server has its own set of engines. Alright, in those engines is where the composite is running the components. Now what you are seeing here, the default is the partition. Now partitions of SVA have no specific functionality as such except for grouping the composites. Other than that, there is no other functionality really. So if you see here, the default partition, I have just deployed the application that we're seeing. So let's say here I'm going to undeploy it. We will do a deployment again. I was just testing yesterday. No, deployment of composites is through Enterprise Manager. This is not a Java application, so we don't use console anymore. If we are deploying a Java based application, we will be using console. Here this is not a Java based application, this is a BPEL based application. That's how to put it in a precise way. So here, composites are deployed through Enterprise Manager. Composites are not deployed through console. Console is for Java based deployments. When you get a SOA based composite, you have to deploy it using the Enterprise Manager because it goes to the SOA infrastructure. SOA infra here you have. Now inside SOA infra you can have multiple partition. A partition is a logical grouping of composites. So you can have composite 1, composite 2, composite 3. All of them will go into a default or any partition. Now normally in any company what usually we do is, let's say there are departments, HR department, then there is a finance department, then there is a sales department, there's a marketing department. All the applications related to one department can be combined into one group and they can be deployed into a partition. Now the only facility that partition provides is this thing. You can select a partition and say shut down or undeploy all applications on this partition. This is undeploying. The same way you can say start up all applications on this partition, shut down all applications on this partition. This way it makes it easy to manage a group of applications. Other than that, the partition has no other functionality. Sometimes you will wonder this, these partitions are useless. They are pretty much useless. So here you can create partitions, you can delete the partitions. The default one is available is what we call default partition. So if you want to create a partition, let's say, alright, so here this is for deletion of the partition. If you want to create, click on the server info here. There is a menu, here. Once you click on something, you always get a menu here. The same menu can be found by right-clicking this thing also. I'm doing a right-click. These are the two ways you get the same menu. See here. I can right-click server infra. I got this menu. Instead of right-clicking, the way I'm going to use is click on it, let the page load, then I go to the server infrastructure, look at the drop down. This is the same menu. So we will be using this method only instead of right clicking, because if I right click, you won't know I have right clicked. So I'm going to do like this only. Click on it, server infra, let the page load, then use the drop down. Now if I have to create a partition, I have to go here, manage partitions. You can do right click also, do whatever you are comfortable. But in our class, I'm going to follow this process. Click on it and use the drop down. So manage partitions, click on it. You can create any number of partitions here. The one you already have default partition. You can create, let's say, HR partition. Create it. It gives a definition here. Partitions are logical grouping of composites that help you manage deployments. Other than all the composites can be shut down or started at a time. So HR you have started, let's say finance is another thing. That's it. Other than that, the partition has no other meaning. Now there are certain things about partitions. You cannot rename a partition. So if you want to change the name of an existing partition, you have to delete it, then create a fresh one. You can't rename. And there should be at least one partition for server infrastructure. And the one that comes default is called default partition. Now here you will be allowed to deploy applications to multiple partitions. And another important thing that you need to observe is the same application can be deployed to multiple partitions. Means if it is a regular Java application, if you are using console, you cannot deploy the same application multiple times. But if it is a server composite, let me show you that one. Let me first deploy an application. So I'm going to click on server infra, then go in here. I'll talk about this entire page once we're done with the deployment. Go into deployments. Here you can do deploy, undeploy, redeploy stuff. Let's do a deployment. Now here, if you get a deployment, you can select it from the laptop where we are opening this enterprise manager, the first option, or we can select the composite from the admin box. Now normally in real time, obviously we won't have composites on our desktops. It's a better practice always to keep them on the server. This is more for a developer. You can select this. This was introduced from 11G onwards. Till 10G of WebLogic, you should have your archive on the admin box. But in 11G, you are allowed to choose a file from the desktop where you are working. But in real time, you don't usually do that. You have a staging directory. From that location, you want to choose it. So here also, Even though I have opened the enterprise manager on my laptop here, we are still connected to the cloud server and our application is on the cloud. So I'm going to give the path of the application on the cloud. So my application is available here. If you say encode IT apps, this is the composite that I'm trying to deploy. So let's give the path of this composite. Home encode IT apps. And give the name of the composite. This is the name of the revision 1 we're going to deploy. That's it. Now configuration plans, I'll come to the configuration plan later, but for now we don't have a configuration plan. Configuration plan is basically to change the internal parameters of inside this jar file dynamically at runtime. I'll tell you about configuration plans later. So here, we have the composite. We're given the path of the composite. Now move on to next here on the right side. This is the second screen. In the second screen, you are asked about the targets, just like WebLogic, a Java application deployment. This is a target. Here we are targeting to serve server 1 because we don't have any other server infrastructure. And the partition, we have these number of partitions. You can target it to any partition you want. So we target it to default partition in this case. Once you're targeted, move on to next. That's it.
So while accessing the application, partition won't matter, right?
It will matter. The URL will change. I'll show you that one also. A default partition will have one URL, another partition will have a different URL. Now what we are seeing here is it's more like a side-by-side deployment. A WebLogic side-by-side deployment allows multiple versions of application to be available. Now, which means version 1 of application and version 2 of application can coexist, but there is a slight difference. If you have version 1, version 2, as an end user, we cannot decide which version we want to access in WebLogic. But SOA allows you, to access multiple versions using different URLs. One of those multiple versions you can specify as a default revision that will have a common URL. You can have other versions. So for example, if we see composite that we are deploying here, revision 1, I can deploy revision 2 also and access it parallelly. This is usually, let's say there are a set of clients who are accessing the old version. Then we have upgraded our composite. So our current version is 2.0. That is actually the default version that we want to run. So our application has been upgraded, new features have been added. So the current default is revision 2. But there are some of our clients who don't want to use 2.0. Means they still want to use 1.0 because of compatibility issues with their own software. So in that case, we can keep 1.0, give them a URL to access 1.0. A 2.0 is going to be a default version, which all the clients who are willing to use a new upgraded version. So like that, SOA allows you to have multiple revisions at a time, and one of these revisions is going to be multiple. Usually the latest revision, you will designate it as a default revision. If somebody wants the old revision, it will still be on the server infrastructure. They can still access it using a different URL. So let's say here, because this is the first thing that we are deploying 1.0, obviously this will become the default revision. Deploy now. That's it. Only 3 steps. You have given the jar file, you've given the partition, third step you are deploying. When you deploy, let's see what's happening here. Let's go to the domain home. Okay, let's see here. So your composite is actually deployed 1.0. So this is your composite demo application 1.0. If you go to the log file, now when you deployed, what actually happened was the composite was put into the MDS, into the database. This is one slight difference between WebLogic deployments and composite deployments. Composites all go to MDS. So there is a heavy dependency on the database for SOA. So going to students, SOA, Oracle, middleware, user projects, domains, encode. So domain. Let's look at the log file. So server 1. Go to the end of the log. See this one here. It's deployed to MDS, then it fetched from MDS. It says it took about 23 milliseconds to bring it from the MDS, and it's loaded into the engine. The demo application is loaded into the engine. Depending on what type of component is inside, it means it can be a BPL component which will be executed by a BPL engine. It can be a mediator which will be executed by a mediator engine. So it will be loaded into the corresponding engine. Alright. Now this is your composite.
You mean to say, sorry, you mean to say like total application will be stored in the database as some club or blobs or something?
Not that way. It will be extracted and the XSDs, XMLs will be stored. Not as a jar file. Instead, it gets extracted. The important elements get stored to MDS.
So only the references or the complete file?
Only the references, not the complete file. The entire composite will not go there. There are certain parts still on our source server itself.
Okay. Thanks.
Okay, now that we have deployed one application revision, let's say you can actually deploy another revision also. So let's say we quickly deploy another revision. Let's go to deployments. Let's again click on the server infrastructure. So deployment, deploy. The same stuff again, except this time code apps, the next revision. So this is the location, and then this is the second revision. Next. Now remember, this is not possible in WebLogic JE based application. You're deploying it to the same partition again, default, move on to next. Now 2.0 we can designate as default revision, or we can say do not change the default revision, in which case 1 will still be the default revision. We'll see what happens if we change the default revision. If we don't change, let's say if I say default revision is 2.0, the latest one, and deploy the application. It's deployed again. So here I have version 1.0, version 2.0. Now to access this composite or the service offered by this composite, let's look at the URL or URI it's called. We're going to click on the text button here. Now you see the endpoint. This is how you access this URL, or this is how you access the demo application. So here, this is the WSDL. A WSDL basically the endpoint with a WSDL at the end. So if I have to take this, let me take it to a notepad, copy it. This is a WSDL. Alright. A WSDL defines a contract. Our WSDL tells you now the same way. Let me take an endpoint. Copy. You don't have to actually copy it. Once you get the WSDL, you actually got the endpoint also. You just have to remove this one. So this one. This is the endpoint. Endpoint is basically how the end user accesses it. This is the URI or URL that will be used by outsider. And the WSDL, if you access, you will get everything about this web service. So here, if somebody wants to access it, they're going to use this WSDL. Now this WSDL is for 1.0, and 1.0 is not our default revision. 2.0 is our default revision. Let's look at the WSDL and the endpoint URI of 2.0. So I'm going to go back to the Enterprise Manager, take the WSDL and take the WSDL of 2.0. Let's go into 2.0. We'll just compare it. Click on 2.0. Now let's click on test. And this is the WSDL. 2.0 is our default revision. So if you see 2.0, because it's default, see this one, after demo application 1.0, there's no such thing as this. This is missing for 2.0 because the 2.0 is default one. So the URL for accessing the WSDL and the endpoint, both of them will change. Whether it's a default one or whether it's not default one, that will decide the actual URL we have to use. Alright, so the default one usually will have a simplest of all the URLs. Now once you have the WSDL, now to access that, now obviously what we are here looking at is a composite which is offering a service. Now what this composite does, we can actually test it on the Enterprise Manager itself. Enterprise Manager provides you ability to test the composites. So for this composite, if you take the demo application composite, click on test, see this one here. These are various inputs you can give: the request, the response. The testing is available on the Enterprise Manager itself. How many ways can a process be deployed? How many ways a composite can be deployed? Enterprise Manager you can use the same way like WebLogic. You can use Enterprise Manager, you can use ANT, you can use WLST. These are the three ways you can use. Any of these three methods you can use for deployment. Now here you are looking at a request which has to be in the form of an XML, and the response that this demo application service will. Remember, all these things are services. This is actually a service. So somebody will call a service, and for our testing you can use a tree view or a more appropriate way of doing it. This is the input that you will be sending to the service, and it will respond with a response. So this input is a SOAP input. Alright, if I take a tree view, so this one, this is actual input. It's a very simple application. It basically what it does is you test anything, it responds with it will add hello to it and respond to you. So if I add, let's say if I send test and click on test my web service, so basically we'll be calling this endpoint. When you call the endpoint, the demo application composite gets invoked. When the demo application composite gets invoked, what it does, the BPEL inside it takes the input that you have given, appends hello word to it, sends it back to you in the form of a response here. So what I'm going to do now is send this test input in the form of an XML like this to the endpoint. You got it back. You see the response tab automatically launched. And what's the response you got? Hello test. You can look at into the C view. This is the response you got. So this is more for testing purpose, the interfaces. The same testing you can do using a UI like the SOAP UI. So here if you say I have installed a SOAP UI here. SOAP UI is a tool to develop web services. Say SOAP user interface. So if I launch it, I can test the demo application from outside. This is what is actually used in real time. I think we both are familiar, Prasad and Shrikant. You are familiar with SOAP UI. We have it in Cricket.
Yeah, still Srikanth is more familiar.
Yeah.
So this is a SOAP UI. What we're going to do is we're going to test the web service that the demo application provides. So this is leave it. So here, let's create a new project here, new SOAP project. So let's give a name. Let's say demo application. Here, initial WSDL. We're going to give the WSDL of our application. So let's 1.0 is, let's give this WSDL. Copy it, paste it in here. So our SOAP UI is going to contact this WSDL, get the details of the contract, everything. So the SOAP UI will know how I'm going to use all the remaining default settings. So our SOAP UI will know what kind of input needs to be sent. See this one? What's happening? Okay. That's it. So this is your request. Double click it and it will load the page. Here we go. It all looks familiar, isn't it? So here you have a request side on the left box, a response you will see on the right side. A request is this one, left side. So the question mark you are seeing is the input you are expected to send. So here if we send an input, let's say from SOAP UI, then you run it. So you see this button here, green run button. If you click on it, alright, so our SOAP UI is going to send a request to the demo application service, and any response will be displayed on the right side box. So I'm going to click on run. You see, you got it. You see this one? It appended the hello from SOAP UI. So whatever you have sent, the web service received this input in the form of XML. It did its processing depending on what is defined inside. What was defined inside was to append hello to the incoming input and sent a response back to you in a XML again. So that's your SOAP UI normal uses. Alright. The testing, or you can actually test it from the enterprise manager itself. Here, either way it's okay. You can do the testing here or using a SOAP UI. Alright, now here the same thing can be done with demo application 2.0. Depending on if there are any changes, the response will change. Now what we are interested now is when you call this service or when you call this composite, what happened was you click on this demo application. Let's say the service offered by this composite was invoked. Whenever a service offered by this composite is invoked, what we call is an instance created. It's called an instance, means multiple users may be accessing the same service, right? Each of the user access represents one instance. So when somebody accesses the service offered by this composite, an instance gets created. So 101 instance, I think, is the first instance. 102 is the second instance. You can actually look at it. Let's say 101. You click on 101, there is a pop-up blocker. So let's remove that. 101. So we are talking about instance.
So 10,001 is the one which you requested from the test, and the 10,002 is the one which you requested. No, the request from soap.
So yes, that's right. Every time a composite gets called, an instance gets created. What's happening here?
So Anil, in the composite have more than one WSDL published, so we can use anything. I mean, how do we know each WSDL URL in that case?
A composite cannot have multiple WSDLs. This is a composite, one WSDL. This is a composite, another WSDL. Isn't it?
But usually we have in a real time so many WSDLs. I mean, so many services they create, right? I mean, developers.
Yeah, each of the composites will have one WSDL. Yes. In that case, we have to have a list of WSDLs, maintain it in some Excel. The composite should know, what WSDL it has to call. So each of the composites here has one WSDL.
But Anil, you are saying one composite will have only one WSDL, right?
That's right. That's right. That's right.
Okay, so Prasad, if I'm not wrong, probably there will be a multiple services information which will be stored, which will be mentioned in the same WSDL. And this will, WSDL have, right?
No, a WSDL is one service. The service may be internally calling another service. That's a different thing. A WSDL is one service. You send an XML to it, an input. It responses, it responds back to you again with a XML response. A WSDL represents only one service.
Yeah, but in real time they have multiple endpoint services they need to configure for different
Yes.
requirements.
Yes, that's correct. Just like we have multiple applications, Java applications on the same WebLogic, here you can have multiple services, each of them having one individual WSDL.
But then suppose if fetch the data, update the data, those are everything. If they can't create so many, with different composites, right, then become a bunch of composites in a deployed thing, right? So in that case,
it changes from the input. A single composite in your case can offer multiple operations depending on the input. Let's say you have set up a mediator inside the composite. You will say, if the input is about insert, do X. If the input is about update, do Y. So the mediator can perform various different functions depending on the input that it's receiving. So the WSDL will be a single WSDL, but what happens internally changes according to the input we send across. That can be designed.
And one simple question, like say we have a calculator WSDL, say. Okay, so we are having some multiple functions, say add, subtract, multiply, division, or something.
Right.
So we are going to create different WSDLs for different operations, or like one WSDL for all the operations?
No. The composite in your case, the calculator composite, offers all the operations.
Okay.
Addition, subtraction, multiplication, division. Let's say this is 4. Now
Okay.
the input, there is only one WSDL to access this calculator composite. Now the WSDL will ask 3 types, will say you need to send 3 inputs. 2 numbers you have to send, and the operation between those 2 numbers you have to send. So let's say you are sending 1 and 2 numbers and a plus symbol for that, Now you will send it to the same endpoint. Now once the composite receives your 3 inputs, depending on the operator, you can have a mediator which will invoke a certain function. In this case, addition function.
Okay.
You see, the internal operations are different. What actually it's more like a function, a specific function inside a program. If the inputs are x, you will call function 1. If the input is y, you call function 2. Same thing. That can be put inside a composite. All of them are exposed to the outside world using a single service, in which case, in your case, a calculator service. Now the calculator service has one WSDL. What WSDL says? A WSDL defines the contract. It says what are the inputs you need to send and what format you need to send. So for a calculator composite or calculator service that we are saying, its WSDL says you have to send 3 inputs. 2 of them are numbers, 1, the remaining is an operator. So here the calculator is a composite. It has a single WSDL. It offers a service. And external clients can call this service with the inputs that it's expecting. Every time an external client accesses it, an instance gets created. So here if you say for a demo application, we've done it 2 times, one from Price Manager, other from the SOAP UI. So if I'm trying to open this one, this is blocking somehow. Pop-up blocker. Yeah. Let's say here. I will close it. Let's click on the instance 101. Now when you click on instance, you see here there is something called a trace. A trace is nothing but what the instance is doing internally. Means how a composite is designed internally. If you take the demo application composite has one component. It's a BPL component here. If you have multiple components, all of them will be listed here, one after the other. We will see some of other applications which have multiple components later. But this demo composite that just now we have deployed has a single component in it. What type of component it is? It's a BPL component. What it does, it takes the input, attaches or appends hello world to it and gives it back. So a trace is nothing but the flow inside a composite. Now if you click on this specific part of the composite, this is a trial. This is what happened. This is actually you will see in JDeveloper. Receive input, assign, reply, output. This is what was happened. This was designed, this flow was designed by a developer. Now if you see this flow, there is something called a payload. This word will come again and again. Remember this word. Payload, if you say, what's a payload normally? Where do you hear this word?
Packet networking, the packets transferring, we see the whatever actual data is called payload.
That's right. The actual data. Or the second instance or second time where you hear is when our ISRO guys are sending some rocket into the orbit, they say the payload. So a rocket is one that takes the satellite to the orbit. The satellite is the payload. The same, the same way you talk in a network, the content is a payload. So in our case, let's say if I have to give that example of rocket, a rocket is the one that transports your payload. Payload for our ISRO guys is the satellite. So rocket takes the payload or satellite to the orbit. it deploys it into the orbit. So here also this instance is carrying the payload. Click on the payload. This is the payload, the XML input. This input is what we are sending it through the SOAP UI or from the Enterprise Manager console. See? So the instance carries this payload, does the operation, in this case the assign operation, responds with a similar payload. Here in this case the hello is added. So here input, this is output. So for this instance, when we invoked, now try to understand the language that I'm using. There is a composite deployed. The composite is exposed as a service. The contract of the service is defined in a WSDL. A client calls the composite, or a client accesses the endpoint. Composites get invoked. When a composite gets invoked, it's called an instance. Instance has a trace. This is a trace. A trace tells you about a payload. This is a payload, the XML input. Then this is called a flow. So this is in terms of if you are looking at the trace, audit trail here in this case, if you see this audit trail, this is in terms of what we call code. The same thing can be seen in a form of a diagram. If you click on flow,
real time the service may hit so many number of times, so how many, I mean, it can't save all the things. I mean, it will all the instances in a day or something, it will maintain.
yeah, you will have thousands of instances. Thousands of instances. That's the biggest problem of SYA. So this is the flow that you have seen in JDeveloper. The drag and drop model is this. So when you say create a BPEL composite, this is what gets loaded into the JDeveloper. The assign operator, so the developer will drag it, the assign operator, he will adjust the parameters. And when it gets invoked, we can actually see the flow and each element of those flow. So if you click on response, this is a response. This is a payload of response. Flow the same way, input. This is the input. Alright. So audit trail basically gives you payload details. So here what we have is we have an instance and all the details of what is happening in the instance. This is for test input. I think we have sent another input also. Second test, second time when we invoke the composite, this instance was created. This instance has the same flow. If you click on this one, this has a different payload this time. The payload is from SOAP UI. The response payload is attached. The same way you can see the flow trace. Flow, it invokes this one. Alright, so now you understand the difference between a composite, a WSDL, an endpoint, an instance, a flow trace. Alright, they're all related, and those are the things that I have actually put in here at the beginning of this document. So here if I go into the beginning of your document, the first page, see this one. SEA is specifications. It's like JEE specifications. What a JEE specification says, it tells you how you should bundle a jar file. You know, what's the structure. It basically defines specifications. So it's like SEA is nothing but JEE. Composites are the SOA applications like JEE or Java applications. Components are what are inside the composites. Revisions are like versions. We have revision 1.0, revision 2.0. Partitions are logical grouping of these revisions, or logical grouping of these composites. So here, in our case, we have multiple partitions. Then instances. Instances is when somebody calls a composite, or when somebody calls the endpoint of this composite, an instance gets created. Alright, this is where we are. We'll come to the remaining parts. So here, let's come back. Now we have deployed a composite. We have invoked the endpoint of this composite. When we invoke the endpoint, it created a instance. Now this instance has a trace which has a payload. Alright, and you can look at the flow trace like this. Alright, I'll close it. Now there are certain simple things here. The same composite can be deployed to the second partition also. So here, if we want to deploy one more time, let's say solve infrastructure. We have deployed our composites to default partition now. Let's deploy it as partition. Go into our deployment, deploy. Same option again, composite. So go in here. Division 1.0. Alright. Next. Take finance partition this time. On to next. Let's make this the default revision. Partition by partition. We're logically grouping the composites. That's it. You see this one deployed to finance. Now let's look at the difference between the WSDLs of default partition and finance. See, we have deployed the same composite in both locations. If we take the composite on finance partition, let's click on this. Let's look for WSDL, copy it, compare it with the first WSDL we have on default. Let's say the second WSDL. You see this one? This is the partition name. That's how the WSDL name changes. The WSDL changes from individual partition. So there is a partition name also in each of the WSDL endpoints or WSDL URLs. Alright, these are all minor points that you must observe. So the same demo application 1.0 can be again deployed to HR also. But the 1.0, it cannot be deployed to the default one again because it's already deployed. So you can have multiple revisions in the same, and then same revision on it's more like confusing. So you understood the point. Is it? Did not let me. I don't want to go deep into that. That gets confusing. That's the nature of the partition. That's it. There is no other use of a partition at all. Now, yeah, once you have a partition, let's say if you click on this partition default, you can shut down all the composites on this partition. You can start up. The same way you can activate, you can retire. I'll tell you the difference between these things, shutting down and retiring. You can undeploy all from this partition at a time. So that way partition makes it easy. Let's say if you have 20 composites, you're trying to undeploy all of them at a time instead of doing one after the other. A partition makes it easy for you. You can say everything undeploy at a time like that. So here those are the partitions. Now let's move on to the next thing. So here, this is what we've been doing. We have deployed an application. We have looked at composites. We have looked at the WSDL of the composite. We have looked at the endpoint of a composite. Endpoint is nothing but how the client will access this composite. And when somebody accesses a composite, an instance gets created. Composites are nothing but services. Remember that. You are simply accessing a service. Just like a Java application. If there is a Java application, it's called request. When somebody opens a browser and hits a Java application, we call it a request. And that's a Java application. Whereas here in SOA, everything is a service. So we are actually accessing a service when we say we are accessing a composite. We don't say we are accessing a composite, we say we are invoking a composite. There's a slight difference in the terminology that we use. You invoke something and it responds back to you. So you invoke a composite using the endpoint. When you invoke, an instance gets created in the server infrastructure. The instance executes the BPEL logic and responds back to you. Alright, and what happened in that instance can be traced using the trace or a flow trace if you want a visual representation. Then we have deployed to multiple partitions the same composite that we have seen. Alright, and we have also deployed multiple revisions to the same partition. We had default partition, we had revisions of 1.0, 2.0, that also can be done. Now this next thing is the states. It's like deploying and undeploying in WebLogic. Here also you can do a lot of things. Let's say you clicked on, you have this application, demo application. You can shut down this application. Apart from shutting down, there is another thing called retiring a composite. These are called states. Shut down. Let's say I click on shut down. Are you sure you want to shut down the composite? Yes, I'm sure. So it's shut down. Now you can start it up. Are you sure you want to start up? Yes, I'm pretty sure. Start up. The same way you can retire. I'll tell the difference just a minute. So you can retire. See this one. When you retire, what does it say? This composite revision will no longer process any incoming requests and no new instances will be created because you are retiring it. However, this is the most important difference between shutting down and retiring. However, if let's say there is an instance that's already invoked by now, which is in progress, all such instances, alright, will complete. However, all currently executing instances will complete normally. This is the difference between shutting down and retiring. If you shut down a composite, all the instances that are halfway will not complete if you are shutting down. Instead of shutting down, if you retire a composite, all the instances which are halfway will complete as usual. That's the difference between shutting down and retiring. Now in a production environment,
This is like a WebLogic side-by-side deployment, right? I mean, first version current instances will is processed and second version active. The new connection will point into the new version.
similar lines, yes, you can say that. So here in a production environment, you never shut down a composite. The moment you shut down a composite, all the halfway running instances of that composite will stop there. We don't want that in production. If it is halfway, we want that to continue and finish as usual. But the reason why we are shutting down or retiring a composite is we don't want to receive new requests. So you stop receiving requests by retiring it. But if something is halfway, which was already invoked, means which already has an instance, you let it finish normally. So that's the difference between shutting down and activating. Now when you shut down an instance, we say it stops at the point. When you shut down a composite, you don't shut down an instance, you shut down a composite. So when you shut down a composite, the instance of that composite which is halfway will be stopped. Now such an instance which was stopped is called a stale instance. That's one of the states of instance. Now when an instance is invoked, what an instance is doing? It's executing all the components one after the other which are inside this composite. When it is executing those components, it may take 1 hour, it may take 1 day, it may take 10 days, depending on what the instance is trying to do. While this is in progress, if you shut it down, the composite, it will move into stale state, means it won't process anymore. Instead of processing, let's do set and other states. I'll come back to that thing. So here you got started and shut down. These are the two states of a composite. When you deploy an application, it automatically gets started. You don't have to really explicitly start anything.
There is
Then
no prepared state.
no, we don't have such states here. No, when you deploy, either it fails or it started. There are no other states of a composite. The states are for instance. We'll come to that point. So here, so you got either a started composite or a shutdown composite. As opposed to that, there are modes. The modes are active and retired. If an active composite is there, the active composite is receiving requests and it's also allowing already invoked instances to complete. When you retire a composite, it is not receiving requests anymore, but it will allow the already created instances to complete. So the difference between shutdown and retire is, if you shut down, the existing instances will move to stale state. If you retire a composite, the existing instances will continue to function. They will finish normal. So in production, you should always retire a composite. Never shut down a composite. The moment you shut down, all the existing instances of that composite will move into what is called a stale state. Alright. Then that's the difference that I've given here. The shutdown state of a composite is different from the main difference here. It will be in a different way. The main difference between shutdown and retired application, as I said, a shutdown application cannot receive callbacks. It's something like this. Let's say a demo application composite is invoked. What this is supposed to do is, it has to go to database, fetch a record. Alright, let's say that's what this composite is supposed to do. So when we are executing a SOAP UI, so I have sent an input to this composite. So an instance is invoked. The instance is expected to connect to the database, fetch me something. That's what this demo application is supposed to do. Now, before the fetching happens, means while it's in progress, if I shut down this composite, even though the database responds back to this instance will not be able to receive it. Means what this composite is doing, the composite is sending a request to the database. The database is responding back. Now the response back is called a callback. Here if you see this one, it's called a callback. Something like this. Let me give you a very simple example. Let's put it in a simple way. Now let's say this one. So you have a SOAP UI. Let's say this is a SOAP UI and the infrastructure. There is an adapter. So you use the adapter to expose a database. This is a database. So the database is exposed as a service. So you can call the database as a web service. Now this is a demo application composite you have deployed. So this is a demo application composite. Alright, this is exposed as a WSDL outside. So this is a WSDL you're calling. Alright. Using the WSDL, our SOAP UI knows what are the inputs it has to send. So demo application is a service, nothing but in this case it's a service. So demo app composite is exposed outside as a service. Now when a SOAP UI sends a request, an instance is created. Let's say this is the instance. The instance, what is supposed to do? It's supposed to invoke the database service, which is exposed here as a web service. So here, this one is a web service it is. So remember, even if it is a database, it's still a web service from internal SOA. Now when this is invoked, what we are talking is, now I shut down the demo app. Now the instance has called the database service, and the response from the database, which will also be an XML, is called a callback. That's the difference between calling and calling back. So here, if you take for example this one, this side is a call. Alright, and the database which will respond back is called a callback. It's like request and response, but here we call it call and callback. Invocation or callback, we can call it anyway. So call is called invocation, response is called callback. So here in this case, what's happening is, if I shut down the demo app now, the instance here goes into stale state and it will not be able to receive a callback. Instead of shutting down, if I retire this demo application, this instance is allowed to complete as usual. So it makes a call. When there is a response from the called service, it responds back, it receives the callback. Alright. So I hope there are no questions here. This diagram should explain it pretty clearly instead of a lot of talking. Alright, so there is a call, there is a callback. If you shut down an instance, you can't receive a callback. If you retire an instance, you can receive a callback. That's the difference. Alright, now let's go back. So in production, you always retire. You don't shut down. All production composites should only be retired. Now this is a versioning thing that we talked about. That instead of versions, we call them revisions. Revision 1.0, 2.0, 3.0. Right? We can deploy multiple revisions to the same composite, or the same revision to multiple partitions.
So if you follow just that naming convention is okay, or inside also, I mean, some meta file should have the versions?
This naming convention is okay. That should be enough. There is a composite.xml inside, like web.xml. I'm not sure there's a manifest.mf file kind of thing or not. I don't think there is any such file that will have version. This naming convention is enough. You don't need to have the reason why I'm so certain is, you can take this 1.0, rename it as 2.0, you can deploy it. So there's nothing inside. Alright, so one of these revisions will be a default revision. Alright, each of these revisions will have a different WSDL. Again, partitions we talked about. Partitions are basically logical grouping of composites. A partition, why you use a partition? We want to, let's say, shut down all the composites at a time, or start all the composites at a time. That's when a partition is used. Other than that, there is no other way, no other use of a partition. Probably they're going to add certain other usages of partitions in later versions, but for now, that's the only thing. Yes, you can shut down all the composites. You can start all the composites within a partition at a time. Now there's one more thing. You cannot rename a partition, so you have to delete and recreate a partition. And there should be at least one partition on the server infrastructure. And the one that comes by default is called default partition. Now remember one thing, even though you have multiple partitions, all of them are, I'm saying this is a logical grouping, means inside the JVM all the partitions still use the same engines. So the server infrastructure for all these partitions is same, and server infrastructure has only one set of engines. So whether you have a default partition or what you say HR partition, whatever partition that you have, all these partitions are still using the same server infrastructure, which means they will be using the same set of engines. Remember that. So the engines, they're all still same. So partition is only a logical grouping. Again, the last thing, same composite could be put into multiple partitions, even if it is of the same revision. Yeah, 1.0 can be put into default, and it can also be put into HR. That's the default partition. The diagram tells you about the arrow mark. I think we've already seen that one. Instances. We talked about instances. So when somebody invokes a service offered by a composite, an instance gets created. Try to understand the sentence that we're using here. Somebody, a client in this case, a client invokes a service offered by a composite, and when this happens, a composite or the server infrastructure creates an instance. Instance is where the code gets executed. So every request will have an instance. That's very important. So if you are implementing eBay on SOA based architecture, every time somebody makes a purchase, an instance gets created. The instance will track the purchase from the initial point till the feedback. So the instance on eBay probably is running for days. So you purchase something on eBay, so it first creates an instance. The website, let's say, internally invokes a composite. The composite creates an instance. Now that instance will track your process, entire thing, whether the delivery was made or not, whether shipping was made or not. Then if the shipping or delivery is done, it will send you an SMS or email asking for your feedback. So this entire process goes on for days. So an instance can run for days, depending on what we are trying to do with that instance. So that's the instance. When a composite is called, an instance gets created. This is a new point here. I said the instance can run for days, which means if the JVM that is running all this stuff, this is all running inside the source server 1, isn't it? PS-EF, grep for Java stuff. This is all source server. All this fancy stuff we are talking is happening inside the source server. Now what happens if I do a kill-9 on this one? So obviously the instance state, all those things that are halfway will go. Yes, that's correct. They'll fail. So we cannot depend on storing the status of the instance in the JVM. You can't depend on the JVMs. The system might go down, so the JVMs will shut down. In that case, all our instance state will be lost, and we cannot afford to lose the instance state. It means at any point of time we should know at what stage my instance is. Instance is nothing but execution of steps, inside whatever the composite you have defined. Step 1, step 2, step 3, step 4, those steps are getting executed inside an instance. Now at any point an instance can be at step 1 or step 7. If the JVM crashes, you have a problem. So to get rid of this kind of situation, what we usually do, or what SOA does, is the state of the instance gets stored to the database. When an instance is running at frequent intervals, the state of the instance gets stored to the database, and in the database the state gets stored to some tables like this. There are about 12 to 15 tables you will see. They will get stored in cube instance, cube scope, all these things. These tables are in the SOA infra schema. We have created 4 schemas, if you remember. We have created MDS schema, we have created SOA infra, or ISDPM, or a BAM. These 4. Now, out of those 4, the MDS schema will usually store the composite related information, like the XMLs, XSDs related to the composite. So when we deploy the application, or when we deploy a composite, all the references, XMLs, XSDs related to that, will go to the MDS schema tables. And the instance related information means when somebody invokes the composite, it is creating an instance, right? Now we don't know the status of this instance, but in this case the instance is completed successfully. The instance could be running for days, and it's halfway, and each of the instances will be at a different state. So we want to store the state of these instances in the tables, or permanently we want to store it. So it's not that we want to store it in a database. We may want to store it in a table also, or in a regular file also, but Oracle SOA implements it using a database because it will be much more systematic, relational type. So here the storing will be done into a set of tables in this schema. Now this process of storing is called dehydration, and this schema is called the dehydration store. We'll go in depth into the actual tables of SOA infra, actual columns inside these tables later, but to give you a generic idea, this is a very important process. Remember, a lot of questions will come out of this thing in interviews. Now the reason why we have a dehydration store is we cannot depend on the JVM. We want the instance state because the instances will be running for days. We want to keep track of the instance state. Now the instance state, you can't depend on JVM. The JVM can go down at any point. So what we do is we are trying to store it permanently. And where we are storing it? We are storing it in a database. In the database, specifically in the SOA infra schema. SOA infra schema has a set of tables like this. And this schema is called the dehydration store. The process of dehydration is nothing but storing. So you will get a question, what is dehydration? I'll come back to this instance later. I think.
Do we have any document that what are the schema tables and purpose of table, high level information? I mean,
yeah, we'll come there. So dehydration, the process itself is nothing but storing the information of the instance in the database is called a dehydration. The dehydration store is nothing but a schema. The XX is the prefix that we use. In our case, we have used encode 33. That's the prefix. So infra is the actual schema. Alright. So in this set of tables, we are storing the information. What kind of information we are storing, we'll see now. So basically we are storing the state of the instance. Now instance has a lot of information associated with it. The most important part is instance ID and execution context ID. If you go to the composite, if you click on one of these instances, look at the top right side, you see this one? This is execution context ID. If you see an instance, the demo application, now we have invoked the service demo application, it created an instance. But does it mean it will respond from this point to the client, or this composite may call another composite? Is it possible that this composite is expected to call another composite?
Yeah.
Yes, which means when the other composite is called, that will create a new instance, because every time you call a composite, a new instance gets created. So here, let's say an end user is requesting something or invoking a service. The service, in this case, let's say the SOAP UI has invoked a service, the demo application. This in turn has invoked another service internally. Like that, there may be a lot of services that get invoked. Each time a service gets invoked, or each time a composite gets invoked, an instance created. Means, let's say for the sake of actual numbers, the SOAP UI has sent a request, was received demo application. The demo application called 3 different composites, one after the other sequentially. So when this service, when the SOAP UI has invoked a client, there are 4 instances created. One is the main instance that we have called, in this case demo application. Again I said demo application called one more, which in turn called one more, which in turn called one more. So there are 3 more instances created plus the original 4. Means when this request was sent from SOAP UI, 4 instances were created. Each of those instances has an instance ID. This is instance ID. But from an endpoint, means from a user perspective, it's a single request. The SOAP here is expecting a response after all those instances were processed. Means I have to have a mechanism to track the flow of this request across the instances. Very carefully, think carefully here. We have multiple instances in a single request. I made a request. The requester, means the service that I called, has invoked another composite internally. I don't know about that. As a SOAP UI, I don't know that the endpoint that I'm calling is internally invoking something else. I don't care. That's the reason I have SOA. So my response may involve invoking multiple instances. Now if I have to track my request across those instances, I will need a unique ID, and that ID is the execution context ID. Here, every time when a SOAP invokes a composite, a ECID gets created, and this ECID does not change across the composites. It's really important. So here, in this case, the SOAP UI has invoked, this is a SOAP UI, alright, it has invoked a demo application composite. Now the demo app invoked another composite, which invoked another composite, which invoked a composite. And finally, So there is, every time it gets invoked, there is a call and there is a callback. There is a call, sorry, there is a call and there is a callback. There is a call, there is a callback. This is the SOAP UI. The SOAP UI is also it's a call and it's a callback. But for the SOAP UI has to receive the callback, everything has to finish here, all these things. Each of them is a composite. So when I create, so comp2, this is composite 3, which is getting invoked, composite 4. Each composite is offering a service. A composite simply offers a service. So every time I create a composite, there is an instance here. Instance 1. For this also, instance. For this also, there is an instance, and each instance has a instance ID. But to track this single request across these instances, alright, I'm using a across these instances, I need to track it. What I'm using a execution context ID. So the ECID will remain the same across the instances where the instance ID changes. You see? So ECID is basically the one that tracks you where your request is currently. Let's say a SOAP UI, you have sent a request and you are getting a timeout. How do you troubleshoot it? To do the troubleshooting, you need to know where the request is stopping. Means you have to know at what stage it is. So you will track using ECID. Alright. So there are two things to every instance. Every instance has a instance ID, and every request has an execution context ID. And ECID does not change across the instances. ECID will remain same. Alright, let's go back. Now, as I said, a business transaction will pass through multiple composites. Whenever a composite is invoked, a new instance is created. Now, to keep track of end-to-end execution of a business transaction, you're going to use the execution context ID. And obviously, instances are managed by SOAP infrastructure because composites are managed that way. Now, as I said, an instance will run for days, and the instance may fail after so many days. It may finish successfully, or you may want to stop the instance. So an instance finally can go into various states, and these are the possible states you have. It might be running, so it's in progress kind of stuff. It failed for some reason, in which case we call it faulted. We don't say it failed, we call it faulted. So an instance is faulted. Or it can be completed, so no issue, so everything went fine, so it completed successfully. Or it's stale. These are the 4 states an instance can be. A stale, when do you get a stale instance? When you shut down the composite of that instance. We just now discussed, when you shut down a composite, all the instances which are running for that composite will move into a state called stale. A stale instance cannot receive callbacks. Alright? So these are the 4 states an instance can. Yes.
Anil, can we resume the stale instance, any way, from at least from the S4 admin perspective?
Yeah, it's possible. It's possible to retry or continue a stale instance. It's possible.
Is it the same case with faulted instance as well, or like it's gone?
Yeah, it's the same case. Fault, we need to see why there is a fault and take a corrective action. We have a set of corrective actions we can take. I'll show you those things.
Oh, thank you.
Yeah, when coming to that point. So here, the instance can be either it's still in progress, or it's completed, or it failed for some reason, or another composite is stopped, in which case it will move into stale state. Alright, now why an instance fails? We are looking at faulted instances, means why something gets faulted. There can be a lot of reasons why an instance fails. There are three types of faults you will see: business faults, system faults, security related faults. There are the three reasons why an instance fails. Business faults is if you are sending the wrong number of inputs. This is one example. Let's say you have sent 2 inputs instead of 3. The WSDL says you have to send 3 inputs, but you have sent only 2 inputs. So basically the service that you are calling rejects the input that you are sending. In this case, the instance is calling another service, external service. Instance 1 is calling invoking another composite. When this instance is invoking another composite, it did not send proper inputs. So the instance basically failed to invoke the next step. So the current instance is said to be faulted. And what type of fault it is? It's a business fault. Then there could be a second type of fault. Let's say I am the instance, I am trying to invoke a composite or a service offered by a composite, but that service is not available. In that case, obviously I cannot continue, so I'll fail. My failure is called system failure. Then there could be a third type of fault. I have to invoke a service. I need to provide username password to invoke that service, but I provided the wrong username password. In that case, it's a security related failure. It's called Oracle Web Services Manager failure, OWSM. Oracle Web Services Manager. We'll talk more into what Web Services Manager does, what are the various internal authentication, authorization mechanism changes. It will all come into WebLogic security realm stuff. The OWSM is more related to the security realm. But these are the three reasons why an instance can fail. It can be because of business reasons. So here in this case, the calling service or the called service is available, but we are not calling. Let's say we are the instance. Consider ourselves the instance. We are calling a service, but we are sending the wrong inputs. In that case, we will fail with a business fault. The second reason is, the second example, we are trying to call a service, but the service is not available. Then also we will fail with a system fault. We are calling a service, but not passing the right username password. We will fail with the OWSM fault. These are the three types of faults. See this one. These are the examples. So when one of these things happen, the instance is said to be faulted. Now the question is, when instance is faulted, obviously it stopped execution. Now you cannot leave it like that, right? So it's a business transaction, so you have to do something with the faulted instance. In this case, if it is a business fault, probably you have to fix by sending the right number of inputs. If it is a system fault, you have to wait till the other service is becomes available. If it is a OWSM, you need to pass a right username password. Which means when a fault occurs, it's not always possible to it's not always possible to fix the fault. Let's say, for example, a business related fault. Why a business related fault occurs? You are sending the wrong inputs. If this is a fault, I cannot fix or I cannot continue execution of that instance without changing the code. Because if I am sending wrong inputs, something is wrong with the code that I am writing. I need to change the code so that it can send the right inputs. Now sending the code, changing the code obviously is not going to help finish this instance. This instance will be, it will be faulted forever. We cannot fix this instance. Whereas look at a system fault. Why a system fault occurs? The service that we are calling is not available. There is nothing wrong that we have done. So in the second case, all that we have to do is wait till the service becomes available. Once the service becomes available, we can retry it. Probably the instance will continue to run. The same way, the third fault probably is not recoverable. So certain faults are recoverable, other faults are not recoverable. So when a fault occurs, you may be able to recover, you may not be able to recover, or there might be a manual intervention that's required. Let's say here in this business fault, it's possible that you fix the inputs by manually intervening. Let's say you have an interface where all the faulted instances, business faulted instances are displayed, and you go through each of those faults, look at the problems with the inputs, you correct those inputs and say continue. That's a possibility. That way probably some of the business faults can be rectified. A service fault can be simply rectified by retrying it after some time. A system fault. A wrong username password probably cannot be rectified unless you change the code. So certain faults can be rectified, other faults cannot be rectified. So what are the various actions you can take when things go wrong or for a faulted instances? Now these are the various things. They are faulted, faulted recoverable, faulted not recoverable. Some of them can be recovered, others cannot be recovered. Now if you have to recover a fault, what are the various things you can do? These are the 5 things you can do to continue running that fault. You can retry. This is basically for system faults. Why a system fault occurs? The calling service is not available. So we will wait for some time, we retry it. If the service we are calling is available, this time it will continue. We can say abort the instance. This will be usually when you require code changes. You can't move it any further. So you stop it. You abort that instance. Then there can be another thing called
How do we call
rethrow. What is it?
in the retry case? How do we call that service? I mean, in that case, we can't start from client, right? Starting in the middle of something.
No, we
need to initiate that.
Yeah, we will come there. We can do it from the database, or we can do it from the enterprise manager. Fault recovery will come there. So how we do that is most of the times using from the enterprise manager. You select all those faults which are recoverable. Then you say retry. So the instance will try to execute from the state it was failed. We'll come to that point. So retry, or you can say abort. Rethrow is another process. Basically, rethrowing is what we say. Let's say there is a fault handling mechanism. We said if error occurs, do this. Now do this part code is defined in that case. Means what needs to be done if an error occurs. Error handling mechanism. This is usually your in Java you have this thing. The same thing is available here also. You can say what is called if something goes wrong, what it's supposed to do. So if there is a fault, what is called an exceptional handler is designed that needs to be coded by the developer. And as an administrator, we can say let's rethrow the error, see if the exception handler picks it up this time. Now when there is a rethrow, the exceptional handler will do what it is supposed to do. In that case, ideally an exceptional handler will basically do one of the other things. Either it might say continue with ignoring it, or it might manually do something with the data inside the instance. Whatever it is, it's actually coded in the exceptional handler. So here we can say retry the service, we can say abort that instance, we can say rethrow the error and see if an exceptional handler picks it up. We can say reopen the entire instance, means start from the, or else we can simply ignore that fault and ask the instance to continue with it. These are the 5 things you can do when something goes wrong or when the instance gets faulted. Now what you need to do and when you need to do that has to be, it depends on your business situation. It's not possible that you can always retry, or it could be dangerous if you abort, or there may not be error handling if you rethrow, or it's may not be always possible to reopen, or sometimes we cannot ignore and continue. So the business situation will dictate what fault recovery action you are taking. It will be told to you from the business side. It will be processed. From an administrative perspective, we don't really know, or it really, it's logical. You cannot decide that you can always retry a service, or you cannot decide that we want to abort the instance. It depends on the impact. Alright, so from the business perspective, we will know what needs to be done, so that will be project to project specific, but these are the various things that can be done with faulted instances. Alright, now similar to faulted instances, there are something called rejected messages. This is another thing you will come across. Rejected messages. Alright, so I'm going to do one thing. I'm going to stop it here for today. We'll be continuing tomorrow. I have an offline class today, so I'll stop it here for today. And also a couple of guys are not available, so we'll continue as usual tomorrow, 5:45. Alright, if you have any questions, let me know. We'll talk about rejected messages. We will see how to invoke or recover those faulted messages, everything in tomorrow's session.
And that information about the schema, tables, purpose, high level.
That we will come in dehydration store. In-depth dehydration store and managing. That's advanced topic we will cover. The purging, it's called purging. What are the purging policies and the purging models that are available? Which one you should use? That's a very high level, and we will discuss that one definitely. In the same document, you have the tables also, as far as I think I remember. You have the tables of the dehydration store. Yeah, here you got. Go into each of these tables and see what are the columns. This is the dehydration store. See this one? These are cube instance, cube scope, work item, audit trail, each of them. Just have a look at it, from using SQL developer or something. I'll show you, when we are doing it. But if you are really interested, you can do each of these things, and we won't understand anything in that. It's not really necessary, but it's good to have a feel. Alright, any other questions? All today's discussion is more about fundamentals. What is what, how things work around in a server infrastructure, and all of them will come in your interviews. Remember that. So nowadays everybody is asking the fundamentals. Means what's an instance? That was a normal question you will say. What's a composite? What's the difference between a composite and an instance? Alright, what is a fault? What are the types of faults? How do you recover a fault? What are the various things you can do on faults? All fundamental questions. It's really important that you understand the difference between all those things. You need to distinguish what is what. So your sentence, when you're saying something, has to be very precise. It's something like this. A client invokes a service offered by a composite. The server infra creates an instance. Instance responds back. When an instance is running, there might be faults. When there is a fault, there is a recovery. That's the flow of end-to-end flow, request response flow in a so make sure you get used to that terminology. Alright, if you don't have any questions, you can drop off. I'll see you same time tomorrow. And happy Diwali, happy weekend. So have some fun, be safe. Cool guys, thanks very much. I'm dropping off, I'm little running.